Hello everyone, welcome to Techie Talks AI. My name is Afijit and today we are going to see about a very interesting and new development in the field of AI. What if I told you that you could run a powerful AI model like the ones that are behind ChatGPT right on your laptop with almost no setup? Sounds crazy, right? Well, Docker's latest feature, which is the Docker Model Runner, makes it possible. And it's brand new. In this video, we are building an AI chat app from scratch and you are getting it on the ground floor of the game-changing tech. Stick around because by the end, you will be chatting with your own AI-powered Docker. So what are we building today? We are going to build a slick chat app that talks to an AI model like Llama 3.2 that is running locally within your Docker environment. And we are using Streamlit for an awesome frontend and Docker Compose to tie it all together. But the real star, the Docker Model Runner. It's what makes this so easy and so powerful. By the time we are done, you will have a fully functional AI app running on your browser with the help of Docker. Let's get started. So this video is mainly focused on the Docker Model Runner. It is a new feature that was introduced by Docker 3 days ago and it is revolutionary. Till this point, we have been using the Llama tools in order to run LLM models locally on our machines. But with the introduction of this Docker Model Runner, we can eliminate the use of Llama to some extent. Since it is new, it doesn't have all the models that Llama will have available to it, but still it is a good starting point. So we'll see how we'll be able to leverage this Dockerized environment to run an LLM model within our Docker ecosystem itself without using any other tool, just Docker. So let me just briefly tell you about the Docker Model Runner. So currently what we have is we have our machine and inside our machine we have our Docker setup. Now what we will be having is inside this Docker along with the Docker server, Docker will also run the Docker Model Runner. What this Docker Model Runner will do is it gives us a separate space for us to run and manage local LLMs. So our LLMs will run within the Docker environment itself but separate to that of your Docker container environment. So you can have your different LLMs running within this Docker model context and then you can have your different Docker containers or any other application that are running and you will be able to access these LLMs that are running inside the Docker Model Runner. So inside this Docker Model Runner, we will be having multiple LLMs which we will be able to run, which can be accessed from the outside applications or from within the Docker containers itself. Okay, so this is what we are going to understand today. In order to make use of this Docker Model Runner, first we need to unlock Docker Model Runner. And in order to unlock this one, what you need to do is you need to open your Docker desktop. So you can go to your Docker desktop settings. There make sure that you are on the latest version which is 4.40.0 because this is the version that introduced this Docker Model Runner. Once you confirm that your application is up to date, if it is not up to date, make sure to click on this check for updates option and to apply and restart the update. Once that is done, you can go to the features in development section and there make sure that this particular feature is enabled, which is enable Docker Model Runner. It's that simple. Now let's see how we will be able to interact with this Docker Model Runner via the Docker CLI. So the process is similar to how we use the Docker CLI to interact with the Docker server. Only difference is here we'll be using Docker model command. So when you execute, you can use the docker model command. Instead of just docker, we will use docker model. Now let's confirm whether our docker model server is running. So in order to do that, we can execute the command docker model status. So if you execute the docker model status command, if your docker model runner is running, you will be able to see this message: docker model runner is running. This means that docker model runner is enabled on your machine. Next thing that you have to do is to pull a docker model server. So in order to pull the relevant model, you have to first go to the Docker Hub. So you can go to hub.docker.com. Once there, you will be able to see under the catalog section Gen AI, and you have to click this Gen AI option. And once you reach there, you will be able to see all the AI models that are available with Docker. So you will be able to see these models that are available, and it also contains MCP servers. If you scroll down, you will be able to see the different MCP servers that are available within the Dockerized environment. You can also click on this view AI models. This is actually the URL hub.docker.com/u/AI, from where you will be able to see and browse all the model repositories that are available with Docker. So as you can see, the number of models that are available for us to work within Docker is not that high. As of now, we only see around 12 repositories, but definitely more will be added to this one, so we'll be able to make use of this. And you can see some of the popular models are also there, like the Llama 3.1 model, 3.3, then Ken 2.5 is there, 5.4 is there, Mistral also is there, Gemma 3, QWQ, then Llama 3.2, all these things are available. We'll use this Llama 3.2. The first thing in order to make use of a model is to pull the model like how you do with a Docker image. First, let's look at this particular model details page, which is the Llama 3.2 model. And here it provides you with the command, the pull command, using which you can pull this particular model. And if you scroll down, you will also see what are the different model variants that are available. You will also be able to see the virtual RAM requirement and the size of those variants. So here what I am going to do is I am going to install, or I am going to pull this particular variant, which is the AI Llama 3.2 latest, and it is a 3 billion parameter model, and this is the containerization method that it uses, which has got a context window of 8K tokens, and also it requires only 1.8 GB of memory and virtual RAM. So I am going to make use of this one because since it is a smaller model, most of the machines we should be able to run this. So let's go ahead and pull this model. So let's execute this particular command, which is docker model pull followed by the model name. So docker model pull followed by the model name, and you can specify latest at the end to ensure that it downloads the latest or the variant that we want it to download. So let's execute this. So in my case, I already pulled this model. So in your case, if you are doing this for the first time, it will take some time for the model to pull the data. Here you can see I have the model pulled successfully. This pulls the model straight into Docker, ready to run with GPU acceleration if you have got it. Initially it will be downloading, and within few minutes, depending on your internet connection, you will have your LLM model available within your Docker model runner. Okay, in order to see the list of models, you can execute the docker model ls command. It will show the list of models that you have available within your machine. As you can see, I have multiple models downloaded, but the model that we are interested in for this particular tutorial is this AI Llama 3.2 model. So this is the model that we will be using. In this video, we'll connect this particular model to our front-end application. But before that, let me just show you how you can use the Docker CLI itself to connect to this particular model. In order to run a model, we have to execute the Docker model run command followed by the model name. So in my case, the model name is going to be this one, a/llama 3.2. So I'll use that a/llama 3.2. And if you want to query something, you can use the syntax that you will use to override the CMD when you run a Docker container by passing the query directly as a parameter. So you can ask, say, what is 2 plus 5? So what will happen is, if I execute this particular command, it will run the a/llama 3.2 LLM model. It will query the model with this particular question, and it will get the response and display the response back. So I am going to execute this. So now this is querying, or this is for starting the LLM model, and then it will be querying the model. And within a few seconds, I should get the response. See this, I am getting the correct response, which is 2 plus 5 equal to 7. As easy as that. Now, if this is not what you want, if you want to have an interactive session with your model, that also is possible. You can execute the Docker model run followed by the model name and just press enter or execute it. So now the model is running and your terminal is connected to that particular model. So now I'll be able to interact with it directly. I'll be able to say hello, and see, it is responding back with how can I assist you today. So what is the capital of India? So let me just ask this, and it is giving the correct answer. Then let me ask, say, what is 4 plus 8? And it is giving the correct answer, which is 12. Then let me ask you, say, who are you? And see this one, it is a llama model. And if you want to exit from this, you can just type /by and it will end the chat session. You can execute the Docker model help command to see the help of the Docker model runner commands. Now that we know how to pull a Docker model and to run the Docker model, let's see how we can interact with this via API call with the help of a front-end application. So stay tuned, this is where it gets exciting. So the code for this particular demo is already there in the shared repository. The link to the repository you will be able to find in the description below. Once you clone this TechieTalks AI repository, you will be able to see different directories. So here you have to go to this Docker model chat directory. So first you have to cd into the Docker model chat directory, and inside this directory you will be able to see different files. So this is the directory structure. So you will be able to see one Docker Compose.yml file, which will contain the code to create and run our Streamlit front-end application as a service. And we also have the front-end directory. So this front-end directory contains files that are related to running our front-end Streamlit application. So it has got one app.py, which is the main Streamlit Python application file. Then you have the Docker file to build that Streamlit application, the Python application. And then finally we have the requirements.txt file, which will contain the Python libraries that you want to install at the time of building the front-end Streamlit application. And finally, you'll also see one nodes.txt, which will contain the commands that you can execute in order to execute this particular demo application. Here you will be able to see the directory structure. You see this is the directory structure, Docker model chat, and here you can see the front-end section. Now let's look at the heart of our app, the Streamlit front-end. Let's look at app.py. So this is our Streamlit front-end application. Like usual, we are first importing the libraries that we want the application to use, and then here we are setting one variable with the URL for the model runner. So the model runner URL we are actually storing as an environment variable. So that environment variable we are getting, and this is the environment variable name. So this environment variable we will be setting within our Docker Compose file, and this is the default value we want it to use if the environment variable is not set. Now we have got a title which is LLM chat interface with Docker model runner, and a chat history that is stored in the session state. And the cool part, the Streamlit's chat input and the chat message options will help you build a conversational UI in just a few lines. And here the user input is properly added within the chat input chat message section, and this is adding the same message to the session state for the history. Now here is the logic which will be performed when the user sends a query. So when you type a question, it hits this URL that is specified in here, and this URL is generated based on the environment variable that we set for the model runner URL, and it will append this particular path which is /engines v1 chat completions, and this is the URL it will be querying. So this URL is used to talk to our model that is running within Docker model. You can also use this URL which is /engines llama.cpp, but this llama.cpp is just optional. So you can use that, or you can use this particular option. And this llama cpp is available because this is still a feature which is in beta version. And how does it connect? That's the Docker model runner magic we are about to unleash. So let's keep going. We are sending this JSON parameter as an input to the URL. So when the URL is queried, it will be queried with this particular data where we have the capability to specify the model. As you can see, I am specifying the model which is AI Llama 3.2 latest. That is the one that we pulled earlier, which we were able to query using the Docker CLI. And then I am specifying the message, the user message. I am using the prompt, which will be the prompt the user types within the chat input, and this prompt is what will be given as input when I query the model within Docker. And I can also set the max tokens to be sent. This you will be able to adjust. You can even remove this section and execute. And under this messages section, you can also set the system prompt if you want by adding one role called system with the content that you want to add as the system prompt. Now the response of this query will be stored in this response variable, and here we are actually getting only the content from that response and storing it to one variable called bot response. And after that, we are displaying that bot response within the chat input chat message layout as a response from the assistant. And here we are adding that bot response also to the session state, the session history, and this is just to raise an error if there is any error when it comes to communicating with the model runner. To run this app, we are containerizing it using Docker file. So let's look at the Docker file. So it is based on Python base model. Then we are specifying the working directory as /app. Then we are installing the build essentials for Python build operation to work efficiently. Then we are copying and installing the dependencies using the requirements.txt file. And finally, we are exposing this particular front-end application via port 850. We are also specifying the Streamlit as the CMD of the application, so that when the container starts, this will be the application that will be running, which will be our Streamlit application serving our app.py on port 8501. So it's lean, efficient and ready to roll. We'll use this in our Docker Compose next. But first imagine all this power wrapped up in a single container about to talk to an AI model. We are so close. Let's tie it together. Before seeing our Docker Compose, let's also look at the requirements.txt file. So this only contains the Python dependencies that are required for this to work. So these are the dependencies that are required. Now our Docker Compose.yml file. Here is where it all comes together. Our Docker Compose.yml. It builds our Streamlit frontend, maps the port 8501 and sets the model runner URL to connect to our Docker model runner. And that is what we are setting in here. You can see this is building the Docker file by specifying a build context. Then we are using the port to expose that particular front-end service, and we are setting the model runner URL. And this is the URL using which you will be able to access the model runner that is running within your Docker ecosystem. So this is the model runner Docker internal URL. So from within your Docker ecosystem, you will be able to use this to access the model runner via API. And finally, we have the extra host section. So what is this bit? It is a trick to link to the host machine. And finally, you will see the nodes.txt, which will contain the commands and steps that you need to execute in order to run and check this demo application. Ready to run your application? Let's go to our terminal, and here make sure that you are in the Docker model chat folder after cloning the repository, and here let's execute the Docker Compose up-build command. So this will take some time for it to install the dependencies and keep it ready. Since I already ran this previously, it will go a bit faster for me. This spins up the container, so it spins up the front end. In seconds, you will see it live in your browser. That's it, the moment of truth. Now to access this application, let's go to our browser and browse localhost :8501. That's it. Look at this clean chat interface. Let's test it. Let's type hello. So now what happens is this frontend will be interacting with the Docker model runner, which will in turn run the Llama 3.2 model and generate the response, and that response will be displayed in here. See this? So this response is coming from our Llama 3.2 model that is running within our Docker model runner. Now I can ask more questions like, say, what is 4 plus 10? Now you can see the response coming. I'll be able to ask more questions like, tell me a joke. Here see, it is even joking about it. So these responses are coming straight from Llama 3.2 running locally thanks to Docker model runner. So no cloud, no hustle, just pure AI power on your machine. So you did this. You have built a cutting edge chat app with one of the newest tools in tech. Let's wrap up. With Docker Model Runner, you have seen how easy it is to run AI models locally. Just fast, simple and containerized AI models. This is just the start. Swap in different models, tweak the app and make it yours. If you loved this first look at Docker Model Runner, hit that like button, subscribe and tell me in the comments. What will you build next with this tech? Tell me via the comment section. See you in the next video. Thank you.